let's look at an application problem of geometric sequences. We're going to flip on over here to a snip and sketch. This is exactly like what you're going to see in your text involving geometric sequences. We're going to apply with what Javier is doing here with eating chocolate. It tells us that Javier wants to eat less chocolate each day. To achieve this, he decides to start with a 50-gram bar of chocolate and eat half of it the first day, then half of what is left of the bar the second day, and then half of the third, and so on. If Javier starts on Monday, what is the mass of the piece that he will eat on Friday? That's an interesting way of talking about it, mass. Okay, so I'm going to be all over this page here with my work. It's kind of one of the bugaboos with technology here and trying to teach you guys this. So first of all, it looks like we're involved in a geometric sequence. Also, think about it. This is a certain type of exponential growth or decay. So it's really a decay problem with what we've done in the past. We're taking half of this each time. So we can identify, well, the ratio, the common ratio here is that 1/2. And we're beginning with this 50-gram bar of chocolate. So our beginning amount, or our first term, is 50. Again, a nice tie back to exponential decay in this case. Your growth factor would be like your common ratio. That would be the B value. And then your initial amount, A sub 1 is 50. It's your starting amount. It's the same thing as the A value if we're looking at the general form for an exponential decay. Okay, so let's look. What is the formula for this? First of all, to be able to answer the question, because we want to determine what's the mass after so many days. And so we're going to go, well, A sub 1 is equal to 50 times this 1/2 to the n minus 1. For us to be able to then determine how much is left on Friday, we simply got to figure out, well, how many days are there from Monday to Tuesday to Wednesday to Thursday to Friday? So you can count it out. Just like Monday to Tuesday, there's 1 day. And then to Wednesday, there's 2 days. And to Thursday, there's 3 days. And to Friday, there's 4 days. Now, I just want to double check here. But if you look in the text on this, I believe that they are saying the number of days is 5. And so the way I've counted it there is different. So this is an interpretation to these problems. There is an issue with these types of problems because of interpretation of how you're counting time. I'm going to tell you right now, with these application problems, the counting of time will always be an issue. So if you've counted time a certain way and you get a different answer than what they've got in the back of the book, it's because of how you're interpreting time. So they're counting Monday in this case as day 1 and 2 and 3 and 4 and 5. They're getting 5 days in that week because they're going from Monday, counting it as 1 all the way through to Friday. So again, you're going to have to determine what number am I going to use here. We'll stay with the book. The book is saying that our number of days is 5. And so we're going to calculate, well, what is that amount on the 5th day, or the 5th term, also known as A5. So we can use the formula to do that. We're going to put in place everywhere we see n, 5. So we're going to go 50 times 1/2 to the 5 minus 1. Which gives us 50 times 1/2 to the 4th power. Okay, so we're going to put this into our calculator here. We can just type it in just like you see it there. So is this in grams, I believe? Oh, right here, sorry. Yeah, grams. So we're going to end up with on Friday 3.125 grams of chocolate. All right, that is a way of applying exponential, well, I shouldn't say that, sorry, a geometric sequence in this case. Okay, thanks guys. We'll see you in the next video.